Hello viewers, in today's class we are going to solve an important problem from three-dimensional geometry, right? And the problem is related to finding out the equation of a plane, right? When certain conditions are given. Now here we have to solve this problem, and the problem goes like this. Find the equation of planes parallel to the plane 2x minus 4y plus 4z is equal to 7 and which are at a distance of 5 units from the point 3 comma minus 1 comma 2, right? So let us start, and here let us first draw a rough diagram corresponding to this problem, right? So here let us take a plane P1, and this is the plane P1, right? And let us take one more plane, and here we have the plane say P2, right? Okay, so now we have two planes, and here the equation of the plane P2 is given as 2x minus 4y plus 4z minus 7 is equal to 0, right? So here we'll consider this plane as P2, and we have to find the equation of plane P1 which is parallel to this plane P2, right? So P1 is parallel to P2, and here we have one more condition, that is the equation of the plane parallel to the plane 2x minus 4y plus 4z is equal to 7 and which are at a distance of 5 units from the point 3 minus 1 2, right? So here we can take a point say S, and the coordinates of this point S are 3 minus 1 2, right? So now here we have three things. The first one is the point, and the distance of this point S from this plane is given as 5 units, right? And this plane P1 is parallel to P2, right? So I am reading this problem once again. Find the equation of planes parallel to the plane, this plane. So this is the plane P2, and we have to find the equation of this plane P1 which are at a distance of 5 units from the point 3 minus 1 2, right? So the distance, this distance, let us take this point as ST, right? And here ST is 5 units and P1 is parallel to P2, right? Okay, so now here what we have to do, we have to find the equation of this plane P1. Now since P1 is parallel to P2, it means the normal vector to this plane P1 is say n1 cap, and the normal vector to this plane is say n2 cap, right? And when P1 is parallel to P2, it implies that the normal vectors are also parallel to each other, right? Or in other words, we can say that if two planes are parallel, then their normals should also be parallel, and when two vectors are parallel, then their direction ratios are either equal or proportional, right? Okay, so now here the equation of plane P2 is given as 2x minus 4y plus 4z minus 7 is equal to 0. So therefore the drs of n2 vector, that is the direction ratios of the normal to this plane P2, are given by the coefficients of x, y and z, right? So the drs of the normal vector n2 cap are given by 2 minus 4 and 4, right? So the normal vector n2 has the drs 2 minus 4 and 4, and now since n2 vector is parallel to n1 vector, so therefore the drs of n1 vector are also 2 minus 4 and 4, right? So these two vectors are parallel, hence their drs are either equal or proportional. So here we are taking the direction ratios of this vector n1 as 2 minus 4 and 4, right? So now we know the drs of this vector n1, hence we can easily write the equation of this plane p1. How? Because we know that the equation of a plane is given by this equation, that is ax plus by plus cz plus d is equal to 0 is the form of equation of any plane where a, b, c are the direction ratios of the normal vector. And here we are to write the equation of this plane p1, and a, b, c can be taken as 2 minus 4 and 4. So here we can write 2x minus 4y plus 4z plus d is equal to 0, right? So this is the equation of this plane p1, and the equation of the plane p2 is given by this equation. And if we observe the equations of p1 and p2, then we see that this component is same in both the equations, and the two equations differ only in the constants, right? So here the constant is d, and here the constant is minus 7. So we conclude that if two planes are parallel, then their equations differ only in the constant term. And here the equation of p1 is 2x minus 4y plus 4z plus d is equal to 0. So therefore we have to now find this constant d with the help of this condition, that is this plane p1 is at a distance of 5 units from this point S. Now viewers, we know that the distance of a plane from a point is given by, if p is the distance, then it is given by ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square, right? So if we have any plane ax plus by plus cz plus d is equal to 0, and we have to find the perpendicular distance of this plane from this point, that is x1, y1 and z1, then the distance is given by this formula, right? And here the plane p1 is given by this equation, and this point can be taken as x1, y1 and z1, right? So now the distance p can be written as here the equation ax plus by plus cz plus d is equal to 0 is given by this equation. So now we have the distance p as 2x1 minus 4y1 plus 4z1 plus d divided by square root of a square plus b square plus c square. So here a is 2, b is minus 4, c is 4. So we have 2 square, then we have minus 4 square, and here we have 4 square, right? And this distance p is equal to 5, right? So now we can write 5, and here x1, y1, z1 can be taken as 3 minus 1 and 2. So we have 2 times 3, then we have minus 4 times minus 1, and here we have 4 times 2 plus d, right? Because this d is to be determined, right? And in the denominator we have 16 plus 16, that is 32 plus 4, that is 36, right? And now this expression is 2 3s are 6, then we have plus 4, and then we have 8 plus d over 6, and we can write 5 is equal to, this is 12 plus 6, 18 plus d over 6, right? So now we have to solve this equation, right? That is mod of 18 plus d over 6 is equal to 5. And we know that if we remove this absolute value sign or the mod sign, then we have 18 plus d over 6 is equal to plus minus 5, right? Because we know that if mod of x is equal to y, then x may be taken as plus minus y, right? So now here we have two equations. The first one is 18 plus d over 6 is equal to plus 5, and the second one is 18 plus d over 6 is equal to minus 5. So we have two equations, one corresponding to the positive sign and the second one corresponding to a negative sign. So now we can solve it. 18 plus d is equal to 30, so d is 30 minus 18, that is 12, right? And here we have 18 plus d is equal to minus 30, and d is minus 30 minus 18, and d is minus 48, right? So now here we have two values of d. The first one is 12 and the second one is minus 48. So now the equation of this plane P1 can be written as 2x minus 4y plus 4z plus d. So when d is 12, we have the equation as this, and when d is minus 48, the equation is 2x minus 4y plus 4z minus 48 is equal to 0, right? So we have two equations of this plane P1. It means there are two planes, right? Here we have considered only one plane P1 in the initial stage, but here we have got two values of d, hence there are two planes, right? So these two planes are parallel to each other, and we can draw the planes like this. So here we have one more plane, right? So this is other plane, or we can take it, the first plane can be taken as P1 and the second one may be taken as P1 prime, right? So this is P1 prime, right? And this is how we find out the equation of planes parallel to this plane, which is P2, and which are at a distance of 5 units from this point 3, minus 1, 2. Viewers, here I would like to mention one important concept, right? See, since we have obtained two equations of the planes, right? And here we are given that these planes are at a distance of 5 units from this point, that is 3, minus 1, 2. So this was a rough diagram, but we can write this or we can draw this diagram like this. This is P1 plane, and here we can draw the plane P1 prime, and the point P may be or this point S. This point S may be taken here, whose coordinates are 3, minus 1 and 2, right? And this distance is 5 units, and this distance is also 5 units, and moreover this plane is obviously parallel to this plane, right? So this plane may be taken as this one, and this plane may be taken as this one, and vice versa, right? So this point S is equidistant from these two planes, right? So this is how we solve this important problem from three-dimensional geometry.